Alright guys, so now it's time to have a look at another worked example that covers exactly the same skills as what we've just done, but in this worked example, the linear equation looks slightly different, so let's check it out.
Alright, this question says, sketch the graph of 3x minus 2y equals 12. Now, as you can see, this question here is not being put in the nice pretty little format of y equals mx plus c. So we're going to need to just still go through the same process as what we did before, find the x and y-intercepts, etc. Now, of course, to sketch a graph, what we need to do is we need to have 2 points, as you've seen up here before. Right, now these are generally x and y-intercepts. Let's see if in this case we can find 2 separate x and y-intercepts. Okay, so let's find the y-intercept first of all. So to find the y-intercept, we know that x will be equal to 0. So let's go through and write out the equation of the line here. So you got 3x minus 2y is equal to 12. Alright, so what we're going to do now is substitute in x equals 0. So instead of writing x, we write 0 in brackets. So you get 3 bracket 0 minus 2y is equal to 12. Now 3 times 0 of course is 0, so you're going to get negative 2y is equal to 12, and to get the y on its own we're going to divide both sides by negative 2, divide by negative 2, so you're going to get y is equal to 12 divided by negative 2 is of course negative 6. Therefore the coordinate of this point is x was equal to 0 as we wrote up here, and our y coordinate was negative 6 as we found here. Alright, let's find the x-intercept. Well, we know the x-intercept is at y equals 0. So let's go through and write out the equation of the line once again. 3x minus 2y is equal to 12. Instead of writing y now, because I'm looking for the x-intercept, I'm going to write 0. So you get 3x minus 2 bracket 0 is equal to 12. Alright, 2 times 0 of course is 0, so you're going to get 3x is equal to 12. And we're going to divide both sides by 3 to get x on its own. So you get x is equal to 4. And the coordinate of this, well, we know the x coordinate we've just found is 4, and we made the y coordinate equal to 0, so you get the point 4, 0. So now it's time to sketch a graph using these 2 points. So we're going to use the y-intercept first of all, so we're going to go to 0, negative 6, so you go to 0, and you go all the way down to negative 6, and you plot the point. The next one, the x-intercept, you go across to 4, 0, so you go across to 4 on the x-axis and 0 on the y-axis, so you don't go up at all, and plot the point. We've now got our 2 points, so what we're going to do is get a ruler, and we're going to rule a straight line going between those 2 points and beyond. Make sure we also draw a little arrow to show that it continues on forever. And we're going to write the x and y intercepts using Cartesian points. So that is at 0, negative 6 and 4, 0. Okay, so now it's time to press pause and sketch the graph of the equation 3y is equal to 24 minus 12x. Remember, once you've gone through and done it, press play and check out your solutions against mine. Alright, so sketching the graph of 3y is equal to 24 minus 12x. To find the x-intercept, I make y equal to 0, so I wrote out the equation here, substituting y equals 0 here, found 3 times 0 is 0 of course, and written out the rest as is. Right, then I subtracted 24 from both sides, getting negative 24 is equal to negative 12x, and then I've divided both sides by negative 12, getting 2 is equal to x. So as a coordinate of course, my x coordinate was 2, and my y coordinate was 0 that of course I substituted in up here. Right, to find my y-intercept I make x equal to 0, so you get 3y is equal to 24 minus 12x. 3y therefore is equal to 24 minus 12 times 0, because I'm substituting in x equals 0. Of course when you do 12 times 0 you get 0, so you get 3y is equal to 24. Divide both sides by 3 gets you y is equal to 8. Therefore my x coordinate was 0, and when I had my x coordinate 0, my y coordinate was 8. Therefore I go through and plot these 2 points, so at 2, 0 I put a dot, so go across 2, up 0, dot, and at 0, 8, so I go across 0 and go up 8, 1, 2, 3, 4, 5, 6, 7, 8, plot a dot, and of course now that I've got my 2 points I can draw the line here, with the arrows going at either end. Now, to make sure it's all complete, what I also need to make sure I have is the point 2, 0 and 0, 8. So 0, 8 and 2, 0. And there you have it.
And then maybe, just maybe sometimes, what you'll get is the x and the y-intercepts happening at the very same point. Now, let's stop and have a think about this for a second. That can actually only occur at the origin, that is the point 0, 0. So for this type of example, you need to go about your working out slightly differently. So let's have a look at a worked example that explains exactly how to do this. Check it out.
Alright, so this graph says sketch the graph of the equation 4x minus 3y equals 0. Alright, like always, what we need to do to sketch a graph of a linear equation is we need 2 points. Now once again, these are generally the X and Y-intercepts, so let's first of all see if we can find to see if they've got separate X and Y-intercepts. So let's find the X-intercept first by making y equals 0. Alright, so substituting y equals 0 now into the equation. So first of all, write out the equation. 4x minus 3y is equal to 0. So we're going to get 4x minus 3 bracket 0 is equal to 0. 3 times 0 is 0, of course, so you get 4x is equal to 0. And when you divide both sides by 4, you're going to get x is equal to 0. So therefore, it's at the point 0, 0. Now if it's at the point 0, 0, where it is here, and that means that they've got the same x and y coordinates. So when you go through and find the y-intercept, of course, it's going to be at 0, 0 as well. Let's just prove that quickly. So you get y-int, x is equal to 0. So let's just substitute into the formula now. So 4x minus 3y is equal to 0. Substitute x equals 0 now, so you get 4, 0 minus 3y is equal to 0. 4 times 0, of course, is 0, so you get negative 3y is equal to 0. And when you divide both sides by negative 3, you're going to get y is equal to 0. So therefore, of course, it's going to be 0.00. So I'm going to substitute in 3 for x. Therefore, at x equals 3, y will be, you've got 4x minus 3y is equal to 0. Make x equal to 3 now, so you get 4 bracket 3 minus 3y is equal to 0. 4 times 3 is 12, minus 3y is equal to 0. Subtract 12 from both sides, negative 3y is equal to negative 12. Divide both sides by negative 3. Cancels out here, you get y is equal to 4. So therefore, when x is equal to 3, y coordinate is 4. So now we've got a second point, we've got our 0, 0, and we've got the point 3, 4. So we go across 3, 1, 2, 3, up 4. We've now got our 2 points that I can now go through and sketch the graph using. So we get our ruler, draw the straight line going between the two, draw the arrows at the end of the line to show that it continues on, and we go through and we write out the 2 points that are of interest. So that's a 0, 0, and the other point that we used, which of course was at the point 3, 4. Now the reason I actually chose the value of x equals 3 is because I looked at the number out the front of the y. Now I knew that when I divided it by 3, those 3's were going to cancel each other out. Alright, so it's always good to have a look at the number out the front of a y as a bit of a hint of what to choose in order to make things nice and easy for yourself. And once again, it's time to press pause and sketch the graph of the equation y is equal to negative 3x. Once, of course, you've done this, what you need to do is check your solutions against mine. Alright, so sketching the graph of y equals negative 3x, what you end up getting is the y-intercept at x equals 0, as we know. So I've substituted x equals 0 here. Getting negative 3 times 0 is, of course, 0. Therefore, my x-coordinate was 0 when I substituted in, and my y-coordinate ended also up being 0. Now, because the y-intercept is at the point 0, 0, the x-intercept will also be at that point. Therefore, we don't need to bother going through the whole hassle of finding out the x-intercept. What we can actually do is just substitute in another value for x. So what I've chosen to do is at the point x equals 3. But you could choose any other point. You could choose x equals 2, x equals 7, x equals 473. It does not matter. I've just chosen x equals 3 just randomly. So you've got y is equal to 3x. Now instead of writing x, I've write 3. So y is equal to 3, negative 3 times 3. And of course y is equal to negative 9. So therefore my x-coordinate was equal to 3, which we got up here. And my y-coordinate ended up being negative 9. So I'm going to go through and plot these 2 points now at 0, 0, and at the point 3, negative 9. So you go across 3, 1, 2, 3, all the way down to negative 9, plot a point. Now like always, you need to get your ruler, join the 2 dots, go past them, draw the arrows at the end of the line, and write out the coordinates as Cartesian points. So 0, 0, and 3, negative 9.
Alright guys, you may not actually be aware of this, but linear functions actually happened to be a huge hit back in the 70s. Just ask your parents. Alright, now they're actually that big that what actually happened was they came up with a dance move to represent them. So let's check it out. Okay guys, thank you very much for tuning into today's lesson, which was all about sketching the graphs of linear functions. Now make sure you stay tuned for the very next lesson, which is all about finding the point of intersection between two lines using simultaneous equations. So like always, say hi to your maths teacher for me. Morsey out.